Hi everyone, welcome back to D Squared Classroom and Happy New Year! Today I'm going to talk about balloon pumps and the concept of counterpulsation, which is really near and dear to my heart, pun intended, because it's the place that I got started in my medical device career. The first device I worked on was called C-Pulse, and it was a balloon pump intended for chronic heart failure patients, whereas traditionally balloon pumps were used for acute scenarios like cardiogenic shock. So I'll explain what counterpulsation is. So to understand a balloon pump and how it works, you have to understand the concept of counterpulsation, which basically means you're pulsating counter to the action of the heart. So the heart pumps and then the balloon pumps, and then the heart pumps and then the balloon pumps, and then the heart pumps and then the balloon pumps, and that repeats over and over. So where exactly does this balloon pump go? Well, to revisit the aorta, it's the vessel in the body that carries blood from the heart out to the rest of the body. And there's the ascending portion, which is closest to the heart, and the descending portion, which goes down and to the rest of the organs and vessels in the rest of the body. And so the balloon pump traditionally would be in the descending side. And it's an actual balloon that rests inside of the descending aorta, and it has a connection, a line that exits the patient and connects to a computer that's going to control the inflation and deflation of that balloon in time with the heart. During systole, which is the time when the heart is actively pumping and the aortic valve is open, the balloon is going to be deflated so it can allow for blood flow around the balloon to get out to the rest of the body. So essentially, when the heart is working, the balloon is inactive. Then, when the heart is at rest, which is called diastole, that's when the balloon actually inflates. And what happens is you get a little extra push of blood beyond the balloon, so you get a slight increase in cardiac output. And because the aortic valve is closed at this point, the blood that goes in the opposite direction back towards the heart is actually going to go to the coronary arteries. So you end up with an increase in coronary perfusion, which can actually provide more oxygenation and nutrients to the heart muscle itself. In case you were wondering, it's helium that is inflating and deflating that balloon. So that's the intra-aortic balloon pump, which is the traditional device. A newer concept is that of the extra-aortic balloon pump, which is a cuff that wraps around the outside of the ascending aorta and connects to an external driver. And much with the other balloon pump, it's going to allow for blood flow during systole, but then during diastole, there's a balloon housed within that cuff that's going to inflate on the aorta and push some blood flow forward and also increase that coronary perfusion. So there are obvious physical differences between the intra and extra-aortic balloon pump, and there's different target populations. The intra-aortic balloon pump is really used in an acute scenario in the hospital, whereas the C-Pulse, which is the extra-aortic, patients can go home with that device, so it's used to treat chronic heart failure. But either way, the benefits are going to be the same. As you increase the work of the balloon, you're decreasing the work of the heart. So to review those benefits, when the balloon is inflated, you're increasing coronary perfusion. Again, that's feeding blood flow to the actual heart muscle via the coronary arteries. And that's going to make the heart really strong. Then you deflate the balloon just before the heart is about to eject blood into the aorta. And so that reduces the afterload, which is the pressure against which the heart has to pump. And basically that means with each pump of the heart, you get more bang for your buck. Thanks for listening, and I'd love to hear your comments or questions, so please feel free to reach out.